All right. Hi, everybody. So this is DRAT, where we talk about some random technical topic, not totally random, something that I know about. Last week we talked about HTTP, kind of just all about what, what's the deal with HTTP? What is it kind of like made up of, and how does everything we do professionally kind of work? Today, we're going to kind of build on that by talking about GraphQL. So we've all used GraphQL in our projects, or most of us have. And I think we all kind of know what it looks like at a sort of cursory level. But I thought it'd be interesting to kind of walk through like what is really happening, what a GraphQL request really looks like, and how servers are typically implemented. And yeah, if you have any questions or want me to dig into any like details as we go along here, let me know. So I wrote a GraphQL, simple GraphQL server. This is, based on GraphQL or Express GraphQL, written in TypeScript. There's a nice graphical playground that you can mess around with to actually, see or visualize the schema and everything. I think probably if you use GraphQL, you've kind of seen this this interface. But basically, what it allows you to do is to dig into the actual schema and look at different parts of it, and then to actually execute commands and see their GraphQL queries and see the response. So GraphQL is typically is sort of a based on HTTP. So this is an API definition language and query language that are serviced via HTTP. But actually, you don't need to, this sort of how we talked about last week, that HTTP you could, service through paper mail if you wanted to, rather than over TCP/IP. You can actually, GraphQL is a protocol that you could service on in other ways, and so just to kind of show that, I wrote this basically way of executing a query against a schema, which is this schema that we defined up here, just in process. So what's going to happen here, rather than starting an HTTP server, it's actually going to execute this against, like just in process. So this GraphQL call is kind of doing the magic. It takes in this schema object. This schema object is created by this build schema call, and the root value is the thing that basically has the executable code that corresponds to parts of the API. And then you pass in this source, which is just a query. So this is just a GraphQL query. It's written on a single line. rather than broken out into multiple lines, but that's the same, basically just a generic GraphQL query. And then when it gets the result, it executes synchronously, well, actually as a promise, but once it executes this query and invokes the callbacks that we defined up here, it's going to just print out the JSON version of what you input, and this is it right here. So before we even get to like HTTP and all of that, GraphQL is just a way of orchestrating a bunch of calls to some callbacks that you provide. This is true of, this is true in JavaScript or TypeScript, but it's also true in other languages. So most languages at this point have a GraphQL server implementation, and they all kind of work pretty similarly. There's one important distinction in terms of like the implementation of GraphQL server libraries is whether it's schema first or code first. So in this case, I've defined this schema, which just has this single query type. And then I've generated, I've sort of like compiled that into something executable with this, by using this root value, which contains the callbacks for the different fields. But there's also a way that you can write this in using this JavaScript library, which is like code first, which is basically it looks a little bit different, and you don't actually end up with like a literal string representation of the query. It looks something more like, schema equals new GraphQL schema. Let's see if, yeah, so thank you, Copilot. It looks something like this. So you can see here that rather than defining the schema in text and then sort of almost like compiling it, you're actually creating objects that represent that schema, and then you can pull out the textual representation of that schema from those objects in the code. So that's another way to write it. Generally, my preference is schema first, because it makes it more explicit, like what this, because many clients potentially will be sort of sharing this schema. I like to have like an explicit artifact for the schema itself that can be shared, between clients and the server. But this particular JavaScript framework supports both approaches. Okay, so what are these things here? These callbacks, we've been calling them callbacks. These are really, they're actually resolvers in the GraphQL nomenclature. Resolvers are typically, just some function that returns some value that satisfies the schema. So the simple example here is this this field called bar, so this string field, returns, this literal string bar exclamation mark, and that is what queries that request the bar field from the schema. This is the function that will execute and the value that will be returned from that. There are, this means that like, even for sort of more complicated types. So let's say, we define another type, and let's give it an ID. And let's say that we're going to say, we're going to return a composite type here. Instead of a simple primitive string, we're going to actually return a nested type here. We actually would define this. We can define this in a couple different ways. I think this will work. Let's give it a try. So let's say the query is might. Actually, let's use the HTTP server because it'll be easier to play around with GraphQL. So I gotta reload this, I think. My type. Okay, so I made this query for my type. My type has a nested field called ID, which I also requested, and you can see that that was returned. That was the object basically that we returned from the my type resolver. This, this is not a primitive type. This is actually returning a more sort of complicated object. But this is a fixed value, right? ID here is a fixed value. But what we could do is actually make this in itself a function which let's do that. Oh wait, this is not going to work. ID. Why doesn't it like that actually? What did I do wrong?
You got too many brackets.
Do I have too many brackets?
You just want to return the async function, right?
There we go.
Yeah.
So we are going to, I'm just making a colon. I think I had the right number of brackets, didn't I? No.
I think you're missing a circular round bracket after 32.
From where?
Scroll up. It's nesting all those methods, the resolvers.
I don't think so. I think these are fine. I mean, I'm definitely doing something wrong. Okay, whatever. There we go. Okay, so you can see that we returned as this field this async function, and which just again returns a fixed value, but we could return something that we computed in here as well. So like maybe we do actually date time dot now. Datetime is not defined. Really? Let's try that. Yeah, okay. So we can actually have a value that changes rather than a fixed value. So so basically what you end up with is kind of this tree of fields. Each field can be an object in itself that's returned, or a primitive like a primitive object, or it can be a function which does a calculation. Some other interesting things about this is if I, I can actually query the same field multiple times. So, well, I think I can. Just shit. I don't know why that doesn't work actually. Oh, maybe I need to call this. Yeah, I probably need to call this. I type 1, I need an alias. Okay, there we go. So by aliasing it, we can actually have basically the client can decide, what the fields are actually called in the result, but ultimately the value that's being computed is coming from the schema on the server. So this is actually, it doesn't look this way, but this is actually executing my type, this function that we wrote here, this datetime function. It's actually executing it multiple times. And, if we got lucky, oh, there we go. If we got lucky, we could see that it was, the 36 milliseconds, this was executed at 36 milliseconds and this was executed at 37 milliseconds. So different invocations of the same resolver. So in addition to being, so another interesting thing about this is that, you can request the same field multiple times. Another thing to bear in mind is that the actual execution of resolvers inside of a query may be out of order. So it's not, if we do, this, can I return null? Yeah, you're right. So, and cannot represent, yeah, that's supposed to be an integer, okay. So you can see that we asked for foo, bar, and baz here. It returned, the server returned those fields in order. But if we actually look down here, I'm just going to actually execute this one more time. If we actually look down here, I console logged when these fields are actually returned, by the resolver. And you can see that it was actually executed. Let's get rid of Baz, actually. This is more. So it returned foo and bar, but you can see that the execution order was actually bar, then foo. So what's happened here is that both of these foo and bar resolvers were called in parallel. So they were called as in JavaScript, they were called as promises. And because what I did with foo is actually set a timeout, I waited 200 milliseconds before actually resolving the promise that I returned. The console log here for bar happened before the console log for foo. And so what the GraphQL spec, specifies, or I mean, maybe it doesn't specify anything about execution order on queries, but basically what happens is, the server, it's up to the server to decide how to sequence the resolver calls in the query that's actually being executed. So what that means in practice depends on the server that you're using. I know, for example, in Go, the GQL gen server library will, by default, I believe it has a concurrency of 10. So if you had, 10 or less fields requested at the top level, it would spawn 10 Go routines to service those resolvers in parallel. And then, it would batch them up. So, as resolvers finished, it would schedule, more resolvers if you requested more than 10 fields. So what doesn't happen though is well, I'll just explain this part. So if foo was a composite type, so there was like field 1, field 2, and bar was a composite type with its own fields, 3 and 4. Basically field, the execution of the nested fields would not happen until the parent had been resolved. So, what might happen in the scheduling is, because bar happened or completed first, bar would execute with it's sort of like whatever value it had, and then the resolvers for F3 and F4 would execute. Then maybe foo would return, which would allow it to schedule F1 and F2 resolvers. So there's sort of like this parallel tree traversal that happens over the resolvers that make up the schema, or the executable schema composed of those resolvers. So this is for queries. So you can also have mutations in GraphQL. Queries and mutations by convention. The idea is that queries don't really change state on the server. Mutations do change state on the server, sort of like get and post. That's just a convention, right? Like you could do whatever you wanted in a get. You could, have a get that deletes your user account, but that probably would be a bad idea. But by convention, queries in GraphQL are read-only, and then mutations actually may change, or should change server state in some way. So mutations look the same. So you can call this a mutation. You basically, like, what I omitted here is that a query can look like this. This specifies that we're making a query. This would specify that we're making a mutation. What I said before about resolver execution order works a little bit differently for mutations. So mutations happen sequentially. So in this case, the resolver for foo would happen, the resolvers for F1, F2. Well, actually, offhand, I'm not sure what the nested behavior is, but certainly the mutation foo, the root resolver, would execute, would finish executing before bar executed, and that differs from queries. So that is a little bit about like how resolvers are structured on the server in most GraphQL server frameworks. there's a lot of other directions we could go here, but any questions about any of the stuff that I described so far?
For the, this is a little bit nitpicky, but for the differentiation between query and mutation as far as changing server state goes, do you have any rule of thumb or comments about cases where the line starts to blur? Like if you've got a query where the client is like viewing a post, but then you also want to add something to like table to
Change the
track.
red state.
Yeah.
Yeah.
Would you, on form, we've isolated that into its own mutation, but it also seems kind of clunky to take that approach.
Yeah, I mean, in that case, I think that the client would probably want to control when something is marked as red, because it might be that it's prefetching a bunch of posts before they're scrolled onto the screen. So the client might have a better sense of what is actually read versus what's just fetched by the client. Or maybe the client fetched a bunch of stuff for like offline viewing. So in that case, I would say probably put, the red state into, put the red, modify the red state in a mutation and have the client explicitly call that mutation, as appropriate. But I think there are other cases where, it's even more fuzzy. So like you can imagine having, logging or something like that. Technically it changes server state or, other things like that. So it is definitely a gray area, and there's not like a sort of crystal clear definition there, but like it's, get and post, I think are similar in the sense that like it's pretty fuzzy what falls at the boundaries of what falls into which bucket, because but I think ultimately like you kind of make the decision based on whether fetching does not imply some action on the part of the user, right? And usually when you're doing a mutation of some kind, it's because the user did something. So that's why you shouldn't tie mutations or changes, server state changes, to gets, because browsers prefetch, for example, right? So like you can't know anything about what the user actually did to trigger that get. But posts, that's a different story, because that almost always, although not always, requires user interaction of some kind.
Makes sense. Thanks, Tom.
Other questions? Cool. So I think that's all that I had for today. There's tons more stuff to talk about with GraphQL, but I think this is something that is really like sort of missed when you first get used to GraphQL. Is like it's a different paradigm than sort of the traditional HTTP request handlers. In HTTP, typically in like an HTTP server, typically you can tie your callbacks or your handlers to some path or some method and path. But in GraphQL, there's this concept of resolvers, and really like the the actual sort of underlying execution of those resolvers is actually like sort of much more prescribed by GraphQL in a way than it is for like how an HTTP server handles a request. The way to think about it is that this tree metaphor, right? Where there's like leaves, which are your primitive fields, and there are branches within there, which are more like composite types, which can nest fields of their own, or nest resolvers of their own. That's a pretty important sort of thing to think about as you're designing your GraphQL APIs. All right, thanks for your attention, and enjoy the rest of your day. How do I stop this?